Hello stats and welcome to 9.1. Chapter 9 is almost identical to Chapter 8. The only difference is here, instead of having one sample, we're going to have two samples. So you have to compare the population from both samples. So like we're going to do a population proportion, and we're comparing from sample 1 and sample 2. And we're going to do the same for the mean and the standard deviation. They should be quick. It's about the same type of data. I hope you do well, and we will not spend a ton of time on this. So make sure you got stat disk open and let's go. All right, our first one is two proportions. So if you remember on the other one, we also started out with proportions, and this is the same thing, except now we're going to have two. So we're going to do a hypothesis test about two population proportions. And we will do a confidence interval just like before, and we will do a test statistic and a p-value, nothing different. Okay, your notation is a little different. When you see p sub 1, this is talking about the population proportion of sample 1, or population 1. There will also be a p2, which is population 2. The same for the p hat. All right, there's a 1, it's about population 1 all the way down. N is for population 1, Q1 is for population 1, then you have the exact same data for population 2, but there will be a 2 underneath them. That's the only thing that you'll see different. The other thing that is different is we will now have a pooled sample proportion. Okay, a pooled sample proportion is when we're putting them together. So the pooled sample proportion is the bar above the P, and it's going to be the x1 plus the x2, so sample 1, sample 2, over how many in sample 1 and sample 2. Nothing different. We're pooling them, we're putting them together. All right, our requirements are pretty close to the same. Both the two simple random samples, they both have to be simple random. They have to be independent from each other. One sample cannot affect the other. They must both have, so the two samples each must have at least 5 success and 5 failures. So same requirements to both populations is what we're looking at here. And they have to be independent of each other. A little different, not much. Now again, you can calculate this by hand. We will be using StatDisk, but if you do get stuck and you need to be home, you can do this without StatDisk. All right, our null hypothesis will always be that they are equal. All right, and then our alternative will be something other than equal, like less than, greater than, or not equal to. Your test statistic is found by the P1 minus the P2. Okay, so your populations, your samples, minus the P1 minus P2 of your population. And these are your pooled. That's what the bar above means. So probability of success, probability of failure over how many you have, if you need to calculate them by hand. We're hoping that this does not happen. All right, we're going to do a p-value and a critical value, both using StatDisk. We will also use a confidence interval, again, using StatDisk. Now, when you look at the confidence interval, it's going to be the P1 minus P2 minus the error, and then your population, your actual population 1 minus population 2, not your sample, and then your samples plus your error, nothing different. Okay, our error again can be found by the z of a of 2, and you're looking at your probability of success and failure in each population. Again, we will be using StatDisk. P-value and critical value give you the exact same. They are equivalent. Confidence interval, again, for proportion is not equivalent to the P or the critical value. It can give you a different answer. It doesn't have to, but it can. Again, our hypothesis test, we will be using, our null will always be that they are equal, and then our alternative will be something other, usually not equal. Okay, here we go. Here's an example. We want to know the proportion of cars with a rear license plate only. Are the proportions the same in Connecticut versus New York? Both of these states require front and rear license plates, but we want to know about if they're illegal or not. So when we go to Connecticut, we have an illegal cars with rear license plates. So we're looking at the ones that are illegal. There's 239 out of 2,049, or 11.7%. In New York are illegal cars. There's 9 out of 550, or 1.6. Now we know this is different because obviously 11.7 is very different than 1.6. Is it significantly different is what we're looking at. So the numbers we're going to need for StatDisk is we're going to need to know our total. So our 2,049, which was given to us. Okay, the rear license plate is what we're considering. So we had 239 that were true. All right, so this is what we're going to be considering a success. So the number of failures was 1,810, both above 5, so we're good. In New York, we had 9 successes above 5 and 541 failures also above 5. So now we've got our totals that we need. If you look, we've already calculated our percentages, and we're going to use a 0.05 significance rate. So let's see if our requirements are met. Are the two samples random samples? We're going to assume that's true and hit yes. Okay, are they independent? Absolutely. The cars in each state do not depend upon the other. Number of successes, are they both above 5? And we've already checked that above, and the answer was yes. So all 3 requirements are met. Very important, make sure they are satisfied. All right, step 1, what's our claim? So we want to know about Connecticut and New York. We're going to assume they are equal. Remember, that's what we're doing here. We're going to assume for our null. So our null hypothesis is that the population proportions are the same. In this case, we're going to do our alternative that they're not equal. It could have been greater than or less than. We're not caring. We want to know if they're the same. So the opposite of the same is not equal. So we have our null and our alternative. Our significance level was 0.05. We're going to use StatDisk to calculate our pooled proportion. Okay, to do this, you go to StatDisk, analysis, hypothesis testing like before, but this time we are on the 2 samples. So make sure you're on the 2 sample 1. Okay, we're going to type in what we want to know. So we're going to do not equal this time for what our alternative is. We have a 0.05 significance. Now on sample 1, there were 2,049 cars. 239 of them only had a rear license plate. In New York, or was it Connecticut? There were 550 cars. 9 of them did not have a license plate, only a rear license plate, sorry. Hit evaluate, and these are our stats that we're going to look at and our confidence interval. So now we're going to use these to check. So the test statistic was 7.10742. All right, I drew this so you kind of understood, but it's not the critical value, so do not get that confused with the one that we usually use. Because this is a two-tailed test, all right, it's two-tailed. So this area over here, we have to multiply by 2 because it has to be represented by 2. So that means we have to take our p-value, whatever it is, and this time we got 0.000. Now remember, that's everybody to the right, so we're going to use 0.001. If you want to do it according to the way the book does, we can use StatDisk only, and that's fine. So we have to take 2 times this value. So this value gets represented in here. So once we take 2 times that value, then we compare this value to the 0.05. So is this greater than or less than? And it's less than the 0.05. So we reject the null. Okay, that was using the p-value. Now let's go over what does this mean. So of course, because we rejected the null, there is sufficient evidence to warrant rejection of the claim of this. That means there is sufficient evidence to conclude that Connecticut and New York have different proportions of cars with rear license plates. All right, because we rejected the null. So we reject that they are equal. So since they are not equal, they must be different. All right, now let's use our critical value. The other one, I should have done this in 7. Okay, our critical value was plus or minus 1.96. Remember, it was a two-tailed test. So we had the negative and the positive. So we have our critical value in. Our test statistic, a 7.11, falls well within our, remember, this is our rejection region. So again, we reject the null, which would give us the same conclusion as above. Now let's look at our critical value, our confidence interval, I'm sorry. All right, when you look at your confidence interval this time, we have a 95% confidence interval. What you're checking is, does 0 fall in here? So does 0 fall in between these two? If 0 does not fall within these two, then we are saying the null is not true. So again, we are saying we reject the null. If 0 falls in there, then we can accept the null, right? Or fail to reject it. All right, all of those are the same. So I hope you did well, and now it is your turn to give this a shot. I needed to give you more information when we talked about this. So we're going to use our survey. I'm going to walk you through the requirements, and then I'm going to let you go on your own to finish this. There's a significant difference between male and female heart rate. So we're looking at our data that we've already collected and a 0.05. So the first step was, is it random? And I know we only collected our class, but we're going to assume you're a random sample. Our second step is, are they independent? And the answer is yes. Male's heart rates do not affect female heart rates, at least not normally, right? And our third is, are they both greater than 5? Well, we're going to assume success means that the heart rate, so your beats per minute, is greater than 70. So since we're assuming greater than 70, now you have to go to your data, make sure you've done that. You've sorted it by male and female. All right, now when you look at this, when I did it anyway, we had a total of 29 females. So females, there were 29, and 16 of them were greater, their beats per minute was greater than 70. And my males, when I did it, there were 24 of you, and out of the 24, I had 18 that had beats per minute greater than 70. All right, I hope that helps you up. Okay, now pause and do your steps 1 through 8. This here is just the requirements. And since these were both bigger than 5, we can check and we can do our project. All right, pause and go. All right, I hope you did good. First thing you should have done was the null hypothesis, which was male and female were the same. And I let the male be P1 and the female be P2. It doesn't matter, they would have both worked identically. Okay, so then the opposite of equal is they are not equal or they are different. So the opposite is they are, that should have been they are different, not different. Okay, the null hypothesis is P1 equals P2. The alternative is P1 does not equal P2. We had a significance level of 0.05. Now, to find the pooled, I used StatDisk. Okay, when you calculate the male, there were 24 of them, 18 of them were successful. The female, there were 29, 16 of them were above 70. So then your pooled proportion was 0.64151. Now using StatDisk, we typed all this in and we get a test statistic of 1.4 and plus or minus 1.95. All right, this is representing this, our critical value. So you got 1.96. It's a two-tailed test. 1.48 does not fall in our rejection region because that's right here. Since it does not fall in the rejection region, we failed to reject the null. Now let's look at the p-value method. P-value had 0.1346. It was a two-tailed test, so you had to multiply it by 2. 0.26 is greater than 0.05. Again, failed to reject the null. Confidence interval. Now we're checking to see if this includes 0. So a 0 between negative 0.05 and 0.44. And the answer is yes. Since it's in between those two, we also again fail to reject the null, which indicates there's not enough evidence to suggest males and females' heart rates are different. All right, you're doing 423. We're going to do our brown eyes, and good luck on your homework. I hope you do well. There is not a work day tomorrow. We will continue on.